Instrumentation and Control Interview Questions, Part 1, for engineers with 5 to 10 years experience in design and consultancy. Intro. Hi, welcome to Insights and Motivation, the channel dedicated to empowering engineers in instrumentation, automation, and control. I'm drawing from my 30-plus years of experience working across consultancy, EPC, and oil and gas operators in the Middle East to help you strengthen both your technical and design engineering knowledge. This session is designed specifically for instrumentation and control engineers with 5 to 10 years of experience, especially those working in design offices, feed, or consultancy environments. Let's begin. What is the key difference between an instrument index and an I/O list? The instrument index is the master register of all instruments, detailing tag numbers, service description, P&ID references, process data, and location. The I/O list focuses on signal-level data, showing how each instrument connects to the control system I/O cards, including signal type, range, alarm limits, and DCS PLC tag mapping. The index manages devices. The I/O list manages signals. Explain how you determine instrument range and set points from process data sheets. Start with process operating and design pressures, temperatures from the P&ID and PDS process data sheet. Select LRV lower range value below the minimum operating point and URV upper range value slightly above the design limit. Set alarms based on process safety margins, e.g. LAL, LAH, PAL, PAH. Validate against control logic requirements and trip set points in C&E diagrams. Proper range setting ensures instruments neither saturate nor give false alarms. How do you select between pneumatic, electronic, and smart positioners for control valves? Pneumatic, used in simple, non-critical loops or legacy systems. Electronic, accepts 4 to 20 milliamp, faster response, suitable for standard process loops. Smart, Hart field bus, for modern plants with digital diagnostics, auto-calibration, and remote configuration. Consultants prefer smart positioners for feed EPC deliverables. They ensure maintainability and future system integration. What considerations go into selecting temperature elements for process design? Key design criteria: process medium, corrosive, clean, or viscous. Temperature range and accuracy. Response time, shorter thermal well length equals faster response. Material compatibility with process fluid and pipe metallurgy. Mounting type, flange, socket weld, or threaded. Follow standards like IEC 60584 thermocouples and IEC 60751 RTDs, ensuring thermal well design per ASME PTC 19.3 TW 2016. What is a hookup drawing and what information does it convey? A hookup drawing shows the mechanical and pneumatic electrical installation details of an instrument: tubing, fittings, supports, valves, cable glands, and junction box connections. It specifies material codes and sizes, mounting accessories, tapping points, impulse line routing. It's the bridge between design and construction, ensuring the correct field installation for every instrument. How do you size and select an orifice plate for differential pressure flow measurement? Sizing parameters: fluid type, gas, liquid, or steam. Process conditions: flow rate, density, viscosity, temperature, pressure. Beat that ratio: orifice to pipe diameter, 0.4 or 0.75. Flow range and Reynolds number. Use vendor or in-house tools per ISO 5167. Always verify permanent pressure loss and straight pipe requirements upstream, downstream. What are the main inputs required to generate an instrument data sheet? Typical inputs include process data, PDS or line list, P&ID tag reference, measurement range and accuracy, environmental conditions, temperature, hazardous area, ingress protection, material of wetted parts, enclosure, and mounting type. Data sheets standardize vendor selection and ensure technical compliance. What are the typical design deliverables prepared by an instrumentation engineer during feed and EPC stages? Feed stage, instrument index, I/O list, P&IDs, control philosophy, data sheets preliminary. EPC stage, hookup drawings, cable routing, loop diagrams, JB schedules, termination diagrams, logic narratives, cause and effect diagrams, and wiring schematics. Deliverables evolve from concept definition to full constructability documentation. What are the key points to verify during a P&ID review? All instrument tags and symbols match the index. Control loops are logically closed: sensors, controller, final element. Correct alarms, interlocks, and trips indicated. Isolation valves, root valves, and drain vent points provided. proper legend consistency with ISA or project standards. A P&ID review is the heart of design integrity. 80% of engineering errors can be caught here. What are the typical control system architecture options used in feed projects? 1. Centralized DCS architecture for refineries and process plants. 2. PLC-based control with SCADA for utility and remote systems. 3. Hybrid architecture, PLCs for package units integrated with DCS. 4. Redundant servers and networks, dual Ethernet or ring topology for availability. Consultants design architecture balancing cost, reliability, and future expandability. End of Part 1. Stay tuned for Part 2, where we'll explore intermediate to advanced questions covering detailed design, vendor coordination, I/O allocation, control narratives, and system integration strategies for consultancy engineers. 10. Instrumentation and Control Interview Questions, Part 2. Intermediate Consultancy Level, Vendor and System Integration. Intro. Welcome back to Insights and Motivation, where we go beyond theory and talk about real-world instrumentation, automation, and control engineering. If you already have about 5 to 10 years experience in design or consultancy, this session is tailor-made for you. These are the kind of questions you'll face when you start leading design packages, coordinating with vendors, and integrating multidiscipline systems during FEED or EPC. Let's get started. What are the key stages of vendor document review in instrumentation projects? 1. Issue of requisition TBE. Vendor submits datasheets and compliance. 2. IDC interdiscipline check. Review mechanical fit, electrical load, and process compliance. 3. Detailed design review. Loop diagrams, GA drawings, wiring, logic narratives. 4. FAT-SAT documentation review. Verify calibration, test procedures, and certificates. Always track review progress using a VDRL, Vendor Document Register List, linked to schedule milestones. What information must an instrument requisition contain? Instrument tag and service description, process range and conditions, material requirements and hazardous area classification, enclosure IP rating, communication protocol, HART, field bus, Modbus, accessories and mounting details, compliance with standards, IEC, ISA, ATEX, SIL. It bridges the gap between process need and vendor supply. How do you verify vendor instrument datasheets for technical compliance? Check process range, accuracy, and response time. Verify pressure temperature ratings match the PDS. Confirm material of wetted parts suits the process medium. Validate electrical parameters, load mount, loop power, signal type. Review certifications, XD, IS, SIL, IP ratings. Non-compliance here leads to costly reapprovals later in EPC. Explain how you perform I/O allocation during control system design. Categorize signals, AI, AO, DO, pulse, HART. Group by system, PLC, DCSIS, and area or unit. Reserve spares, 10 to 20% per card type. Keep analog and digital isolated for noise control. Maintain redundant I/O paths for critical loops. Allocation tables form the base of I/O channel database and marshalling layout. What is a logic narrative and how is it used? A logic narrative is a text-based description of control and interlock sequences. It explains inputs and outputs, sequence steps, startup, normal run, shutdown, alarm, trip conditions, manual auto modes, and fail-safes. It serves as the blueprint for PLC DCS programming and C&E development. What are typical challenges in integrating packaged PLCs with a plant DCS? Protocol mismatch, Modbus RTU versus TCP, data mapping and scaling errors, signal update rate delays, 1 sec versus 100 milliseconds, time synchronization differences, loopback testing during FAT not fully performed. Best practice, use a well-defined vendor interface document, VD, and conduct a joint integration test. How do you define alarm priority and classification in design? Follow ISA 18.2, EEMAU 191. High priority, immediate action, safety impact. Medium, operator intervention needed soon. Low, advisory or informational. Add attributes like color, audible tone, acknowledge requirement, and record duration. Good alarm design prevents alarm flooding during plant upsets. What is the difference between a junction box schedule and a cable schedule? Junction box schedule lists JB tags, location, entries, gland sizes, termination details. Cable schedule lists cable numbers from to connections, lengths, types, and tray routes. Both must be cross-verified in E3D or SP3D model reviews to avoid clashes. How do you ensure consistency among P&IDs, instrument index, and datasheets? Use a central database tool, InTools SPI. Implement auto-tag cross-reference checks. Periodic MTO extraction validation between disciplines. Maintain changelog tracking with revision control. This ensures the single source of truth principle across deliverables. Chat what is the role of a consultant during Factory Acceptance Test FAT. Witness loop simulations and interlock logic tests. Verify graphics, alarms, and reporting. Approve I/O simulation and sequence of operation. Check redundancy failover tests. Sign FAT protocols and punch list closure. Consultants safeguard design intent and functional integrity before system shipment. End of part 2. We'll move into advanced consultancy topics such as control narrative finalization, SILE assessment interface, system architecture decisions, and project documentation control methods for mid-senior engineers. 10. Instrumentation and Control Interview Questions, Part 3. Advanced Consultancy and Control System Architecture. Intro. Welcome again to Insights and Motivation, where we go deep into the real challenges faced by instrumentation and control engineers in the design consultancy world. If you've been working for 5 to 10 years, you're likely handling system architecture, vendor coordination, control narratives, and feed stage technical reviews. This episode focuses on advanced questions that measure your ability to design, verify, and integrate complex control systems, not just individual instruments. Let's dive in. What are the major components of a distributed control system, DCS architecture? A modern DCS architecture includes controllers, processors, execute control logic and P&ID loops, I/O subsystems, field interfaces for AI, AO, DI, DO, and heart signals, engineering and operator stations, configuration, HMI graphics, and alarm management, historian server, long-term storage of process and event data, redundant control and network layers, dual Ethernet or ring topology for high availability, gateways, OPC servers, integration with PLCs, SCADA, or corporate systems. Consultants define this hierarchy during FEED to ensure scalability and cyber resilience. How do you approach the development of a control system architecture diagram during FEED? Follow a top-down approach. 1. Identify control domains, process, utility, safety, electrical. 2. Define system boundaries between DCS, ESD, F&G, and PLCs. 3. Specify redundancy, network topology, and communication protocols. 4. Allocate process areas to controllers for load distribution. 5. Incorporate time synchronization, NTP-PTP, and system security zoning. The architecture must meet availability, 99.9% uptime, and functional segregation criteria. Explain how the consultant validates SIL requirements in design. Consultants perform SILE verification as per IEC 61511 using LOPA, Layer of Protection Analysis, results from process safety. Target SILE level for each safety instrumented function, SIF. Check SFF, safe failure fraction, PFG, and test interval against vendor data. Ensure hardware fault tolerance, HFT, meets design SILE. Deliverables include SILE verification reports, ensuring SIS design aligns with process risk reduction. What is the function of a CNE, cause and effect matrix, and how is it linked to logic programming? A CNE matrix defines the relationship between causes, alarms, trips, and effects, actions like shutdown or alarm. Used by PLC DCS programmers to generate interlock logic. Acts as the testing reference during FAT-SAT. Updated continuously to reflect changes in logic narrative. Consultants ensure consistency between CNE, logic narratives, and control philosophy to prevent logic gaps. What's the difference between BPCS and SIS, and how do they communicate? ASPAS, Basic Process Control System, SIS, Safety Instrumentives, and Control Philosophy. Purpose, Process Control and Optimization, Personnel and Equipment Safety. Availability, highest. Fail state, safe or steady state, always to fail safe. Communication, OPC Modbus read-only from CS, one-way data flow to DCS. Physical and functional separation is a must. Interaction occurs only via secure gateways. How do you finalize a control narrative with the process engineer and client? The workflow: 1. Start from control philosophy and P&IDs. 2. Draft sequence of operations, PID modes, and fail-safes. 3. Conduct interdisciplinary reviews, process, electrical, safety. 4. Incorporate client feedback from HAZOP LOPA sessions. 5. Lock revisions after FAT and baseline it for handover. Control narratives form the functional blueprint of automation. No logic programming should begin without them. How do you decide which control loops go into DCS, PLC, or package controllers? Selection criteria: continuous control loops, flow, temperature, pressure, DCS, discrete logic, sequencing, or machinery control, PLC, safety critical loops, SIS or ESD PLC, vendor package systems, retain vendor PLC, integrate via gateway, balance integration effort and risk. For feed, consultants define control allocation tables early to avoid conflicts. How is redundancy handled in modern DCS systems? Redundancy exists at multiple levels: controller redundancy 102, 203, I/O redundancy, dual channel, network redundancy, dual ring or redundant switches, power redundancy, dual power feeds, UPS. Redundancy design must be selective. Critical systems need full redundancy. Non-critical ones may share. What are the key consultancy checks before approving a DCS vendor's architecture drawing? Controller loading within vendor-specified limits, segregation between process and safety networks, proper placement of servers, gateways, and firewalls, redundancy verification for each subsystem, compliance with corporate IT and cybersecurity policies, expansion provision for future plants or units. Consultants act as technical custodians, ensuring system longevity and interoperability. What are the deliverables associated with DCLC architecture design at FEED and EPC stages? Stage deliverables: FEED, control system philosophy, architecture diagram, I/O summary, vendor interface definition, system specification, DCS, PLCIS, EPC detailed I/O allocation, network architecture, FAT protocols, HMI graphics philosophy, alarm rationalization, cybersecurity design, and as-built architecture. These documents ensure traceability from concept to commissioning, forming the foundation for digital plant integration. End of Part 3. In Part 4, we'll go into advanced project integration topics: multi-vendor system interoperability, cybersecurity compliance, document control strategy, and lessons learned from real FEED and EPC execution for consultancy engineers. Calibrate 10, Instrumentation and Control Interview Questions, Part 4, Multi-System Integration and Project Execution for Consultancy Engineers. Intro. Welcome back to Insights and Motivation, where we explore the advanced realities of instrumentation and control design engineering in consultancy and EPC environments. If you've been in this field for 5 to 10 years, you're probably leading project deliverables, managing vendor interfaces, or coordinating with clients during FEED and detailed design. This session, Part 4, dives into multi-system integration, cybersecurity, and project execution practices that separate experienced engineers from project leads. Let's begin. How do you define and document system interfaces between DCS, ESD, and F&G systems? A system interface definition, or vendor interface document, defines data points exchanged between systems, alarms, trips, status, permissives, signal direction and protocol, Modbus, TCP, IP, OPC, serial, communication network details, IP addressing, baud rate, handshake, data ownership, which system generates, which system displays, testing scope during FAT and SAT. Consultants ensure it's agreed upon early between vendors and client IT to prevent integration clashes. What's the difference between Modbus RTU, Modbus TCP, and OPC UA? Protocol, medium speed, use case. Modbus RTU serial RS485 9.6 to 105 kbps, legacy fieldless communication. Modbus TCP IP Ethernet, modern DCS PLC integration. OPC UA platform independent Ethernet, secure object-based enterprise connectivity and cybersecurity compliant. OPC UA is preferred in new projects for secure, scalable integration under IEC 62541. How do you plan FAT, Factory Acceptance Test, for integrated control systems? 1. Prepare a FAT protocol covering hardware, software, logic, and communication. 2. Include simulation of cross-system signals, DCS, PLC, SIS, SCADA. 3. Verify C&E logic, alarms, trends, historian, and redundancy. 4. Record punch list and categorize findings, minor, major, hold point. 5. Obtain client sign-off before system packing and shipment. For consultancy roles, FAT witnessing confirms design intent, integration logic, and safety integrity. How do you ensure cybersecurity compliance in control system design? Implement defense in-depth architecture based on IEC 62443. Network zoning. Field control DMZ corporate. Firewalls and data diodes between layers. role-based access control RBAC and password policies, whitelisting and patch management, vendor remote access control with VPN and logging. Cybersecurity is now a mandatory design deliverable, not an IT afterthought. What steps do you take to integrate package vendor PLCs into the main DCS? Obtain vendor I/O list and communication philosophy early. Define signal mapping tables with correct scaling and units. Validate handshake signals, start, stop, permissive, trip. Use interface simulators for testing before FAT. Conduct joint interface testing to ensure communication stability. Integration success depends on clear interface documentation and early alignment during design. What is the consultant's role during project execution in multidiscipline coordination? Lead P&ID and model reviews, 3D model, layout. Review vendor deliverables for compliance and consistency. Coordinate with process, electrical, mechanical, and civil teams. Maintain design changelog, DCL, and revision control. Review interface drawings for installation feasibility. Consultants act as the technical backbone, ensuring seamless design integration across disciplines. How do you implement an alarm rationalization exercise during detailed design? Start with alarm list from DCS configuration. Review each alarm with process and operations teams. Assign priority, cause, consequence, and corrective action. Remove nuisance or duplicate alarms. Update alarm philosophy and DCS configuration baseline. This ensures the operator sees what matters, not an overwhelming flood of data. What is the difference between a FAT and a SAT? Aspect, factory acceptance test. SAT, site acceptance test. Location, vendor's facility, site control room, purpose, verify functional logic and integration, verify installation and field wiring. Simulation, using test panels or simulators, using live instruments. Responsibility, vendor and consultant, EPC contractor and client. Consultants witness FAT, clients or PMC witness SAT for final acceptance. What is a master I/O database and why is it critical? A master I/O database is a central repository of all I/O across systems, DCS, PLC, SIS, and packages. It contains tag number, description, system, I/O type, location, scaling, and range, cable, JB, and termination details, communication mapping to HMI or historian. It ensures consistency, eliminates duplication, and drives all downstream deliverables, loop diagrams, cable schedules, logic configuration. How do you manage project document control and version integrity? Follow a document control register DCR linked to project WBS. Use revision numbering 0 IFR, ABC, IFA, 1F3, IFC. Track change history and TQs, technical queries. Lock issued for construction deliverables post-client approval. Coordinate with document control department for transmittal logs. Good document control prevents rework and contractual disputes, a vital consultancy responsibility.